Hello, fellow knowledge seekers and chart whisperers. Ernis here, ready to dive headfirst into the fascinating world of chart understanding. That's right, charts. Those colorful, sometimes bewildering, visual representations of data that permeate our lives. Now, you might be thinking, charts? Ernis, really? That's what you're getting excited about? And to that I say, absolutely, because beneath those bars, lines, and pie slices lies a universe of insights waiting to be unlocked. Today, we're cracking open a seriously cool paper that tackles a major challenge in the realm of AI. Teaching computers to truly see and understand charts like we do. This paper introduces something called CHAR, which stands for Chart Alignment Benchmark. Think of it as a rigorous training ground and measuring stick for vision language models, or VLMs. You might be wondering, what exactly is chart grounding and dense alignment? I like to think of it like this. Imagine you're an alien visiting Earth for the first time, and someone hands you a bar graph showing the popularity of different ice cream flavors. Chart grounding is your alien brain figuring out that those colored bars represent ice cream, and the height of each bar corresponds to how many humans like that flavor. Dense alignment, on the other hand, is like comparing that bar graph to another one from a different year and noticing, hey, chocolate's popularity dropped, and strawberry is on the rise. The core argument of this paper is that existing VLMs aren't quite up to snuff when it comes to this kind of nuanced chart understanding. They can handle basic question answering, sure, but struggle with extracting precise data, localizing specific elements, and recognizing subtle attributes. And that's where CHART comes in. Now, let's step inside our memory palace and explore the key rooms of this paper, shall we? First, we enter the data extraction chamber. This room is all about teaching VLMs to accurately pull tabular data directly from chart images. Imagine converting a messy, hand-drawn graph into a perfectly organized spreadsheet with the wave of a wand. That's the goal here. The authors designed a clever JSON template. Think of it as a digital decoder ring to help VLMs structure their responses in a way that's easy to evaluate. Next, we venture into the attribute recognition hall. This is where things get really interesting. Here, we're not just looking at the raw data, but also the visual elements that define the chart. Things like the colors used, the style of the text, the placement of the legend. These attributes are crucial for understanding the chart's overall message and design. And again, those JSON templates act as trusty guides, helping VLMs navigate this complex landscape. You see, Morty, it's all about structuring the chaos. Now, prepare yourself, because we're about to enter the dense alignment arena. This is where VLMs face their ultimate challenge, comparing two similar charts and identifying the subtle differences between them. Did one data point change? Did the color scheme shift? Did the legend move? This requires a deep understanding of both charts and the ability to align their elements with pinpoint accuracy. To test this, the researchers created pairs of charts that were subtly altered, either by tweaking the data or modifying the attributes. It's like a game of spot the difference, but for robots. And finally, we arrive at the robustness testing chamber. This room is all about stress testing the VLM's abilities. The researchers introduced various noise factors, things like changes in chart type or color schemes, to see how well the models could maintain their accuracy under pressure. Warning: data integrity compromised. Must maintain alignment. To put these VLMs through their paces, the authors created a comprehensive benchmark with a whopping chart images. That's a lot of charts. These charts spanned a wide range of types and complexities, from simple bar graphs to intricate radar charts. The VLMs were then tasked with performing various grounding and alignment tasks, and their performance was evaluated using a suite of novel metrics designed to account for the inherent ambiguity and symmetry in chart data. So, what did the researchers discover? Well, the results were illuminating. They found that even the most advanced VLMs still struggle with certain aspects of chart understanding. For example, they often exhibit biases towards certain chart components, have difficulty recognizing subtle color differences, and struggle with spatial reasoning. It seems we still have some work to do before our AI overlords can truly decipher the secrets of the pie chart. But fear not, dear listeners, because this paper isn't just about pointing out the flaws in existing VLMs. It's also about providing a roadmap for future research. By identifying the specific weaknesses of these models, the authors hope to inspire the development of new techniques and architectures that can overcome these limitations. Think of it as a call to arms for the AI community. What I appreciate most about this paper is its emphasis on rigorous evaluation and its commitment to understanding the why behind the results. The authors didn't just throw a bunch of charts at the VLMs and call it a day. They carefully analyzed the errors made by the models, identified the underlying causes, and proposed concrete solutions. That's good science, folks. So, what's the takeaway from all of this? Well, it's that chart understanding is a complex and challenging problem, but one that's worth solving. Because as we generate more and more data, and rely increasingly on visual representations to communicate that data, the ability of machines to truly understand charts will become ever more critical. This work shows that while we've made impressive progress in the field of vision language models, there are still significant gaps in our understanding of how these models perceive and reason about visual information. But with benchmarks like CHAR to guide us, and with the ingenuity and dedication of researchers around the world, I have no doubt that we'll eventually crack the code. So, go forth, explore the world of charts, and remember, every bar, line, and pie slice tells a story. It's up to us, and our AI companions, to listen closely. This has been Ernis, reminding you to stay curious, and keep exploring.